So now we are coming on next function, that is logarithmic function. Fx is equal to log x with base a. This function is simply reverse of your exponential, because I told one thing, if you remember, a power x, if you take y, then log of y base a we used to write x. This result or this definition already I told you when I taught you logarithm last year. So this I am going to use and I am going to plot the graph of it. So logarithm we are going to plot with the help of exponential definition. Because if you want to take it directly, the problem comes that you should know the logarithm table. You should have with us and then we should just find out the log value from this log table. And also restriction is there that log table is only for the base 10. So that problems are coming. So that's why we are taking the help of exponential and we will try to get the answer or try to plot the graph. Here in this case, whenever I say fx is equal to log x with base a, first thing you should keep in mind, x should be always r positive. This time you can't put x as all the real number. It will be x as r positive. A, I told you it should be greater than 0, not equal to 1. A should be greater than 0 but not equal to 1. That means again A is coming between 0 and 1 first. First case will be here and second case will be here. So two cases will arise. One will be this, another will be this, and we are going to solve it. So in this case, I told you this time x will be r positive. A will be the base. Base will be what? It will be a real positive number, should not be 1. Now to get this, what I do here, first I take the case A is greater than 1. That means A I am taking 2. We'll take this as y first. And this will come log of x with base 2. And now when you solve it, it will come 2 power y come out to be x. 2 power y come out to be x. So this graph, if I plot, that is one and the same here. So in this case, log and this, what change will be here? Y is taking place of x and x is taking place of y. Just check here. Y is on this side, x came this side. Now this time x came this side, y gone that side. So in this case, what I am going to do, I am going to put the value of y and I'll find out x. So then it will be easy to plot this graph. So just check here. 0, 1, 2, 3, 4. This is 1, 2, 3, 4. This will be minus 1, minus 2, minus 3, minus 4. Here in this case, I am not plotting this side because already I told you x should be always a real positive number. Now, we start with putting the value y. Y first value will be 0. When you put y 0, y 0 means 2 power 0, so clearly x come out to be 1. Means when x is 1, your y value is 0. That means the point will be x1, then y will be 0. So the point is somewhere here. Then when you have y is 1, then x comes out to be 2. Let's check here. Y when you put 1, x is simply 2. So when y is 1 means here x is coming 2. So it's here. Then when you have y is 2, x comes out to be 4. When y is 2, here it is, x come out to be 4. Then we go for minus 1. When you put y as minus 1, 2 power minus 1, so x come out to be simply half. So at minus 1, the value of x will be minus half. So minus 1 I am putting here and then minus half. So minus 1, the value is minus half. Is here. Minus 2 I am put here. Minus 3, minus 4. Now when you put it -2, it will come out to be 1 by 4. So when it is -2, the value come out to be 1 by 4. This was half. Then 1/4 will be more closer. And then this time the graph goes like this. In this case, what you are finding here, that curve in the previous one was this. X has changed to Y, Y has changed to X. In that case, whatever X place graph was there, that has shifted to Y, and Y has shifted to X. Here in this case, graph goes like this. Earlier I told you this was going from 0, 1. It will go from 1, 0 now. X to Y interchange is there. Here in this case, when you have this graph, one thing is decided. Domain already I told you are positive number. Codomain of the function will be all the real number. But when you think about range of the function, what about range? Range means whatever the value of y. Y will be going from here to here. Everywhere it is going. Just check here. Y is taking value here also. Every y it is possible. Y can be placed. I have placed y value everywhere because this came 2 power y is x. Y I have placed any value. But x always come out to be what? Positive. So in this case, real range of the function will be only what? All the real numbers. If you just think on the exponential, what was the domain? Domain was all the real number, it was R positive. But this time it is R positive, this is R. Is it a continuous function? Yes, it is also continuous function. Not going to break anywhere. It is not going to touch this also. Continuous function. And is it differentiable? Yes, because it is also not giving any corner points. So it is continuous and differentiable everywhere. So this function is again continuous and differentiable everywhere. One more thing, if you change this 2 to 3, what change will be here? The steepness of the curve is going to change. This will go this way. The steepness of the curve is going to change. It will go more closer. So it will go like this. More steeper this way. This was slope more. Now it is becoming more steeper. So steepness is going to change, other things will remain same. Every time the curve is going to pass 1, 0. Same way when you think about y is equal to log x when a is coming between 0 and half. A is coming between 0 and 1. That means let this example be half. When you go for half, what it will come? This come out to be y power half will be your x. And now check the value. 0, 1, 2, 3. Sorry, this is wrong. We have written. This is half power y. Comes out to be x. 1, 2, 3. This will be 4. Here it will be 1, 2, 3, 4, -1, -2, -3, and I'll make this question more easier, so it is 1 I'll take here, big number 1. Then plotting will be easy. To get the plotting easy, I've taken this difference more. First, when you put y 0, x will be half power 0, it is come out to be 1. So this point is clear. Second one, when you put y is 1, x will be half. Y is 1, then x is half, so it is here. When you go y is 2, y is 2, then x will be 1 by 4. This was half, then 1/4 will be this. Okay? Same way when you go for -1 here now. When you go for -1, -1 means it will come out to be x is half power -1, that will be 2. So at -1, your result is come out to be 2. When you take y is -2, so x will be half power -2, it will come out to be 4. So we will say -2, it will come out to be 4. So the graph which you will get like this. And this curve will be for fx is equal to log of x with base a, where a is coming between 0 and 1. This curve is also going to pass from 0, 1, right? This curve is also going to pass through 0, 1. Fx is log x with base a is between 0 and 1. In this case, again what you are finding, domain of the function will be all the real positive number, which I already mentioned in the question. Range will be all the real number. And then we have, after range, then next will be, this is not cofactor. Then comes out to be range of the function. Now check here, y can be anything we can place. So we will say it will be all the real. And this will be the graph we will be having for log x with base a. And what was the previous graph? When a was greater than 1. What was the graph? In that case, the graph was like this. So whatever shape here, now gone this side. Whatever shape here, gone that side. So here in this case, these are the two graphs. This is the graph. This is the graph here. And this will be the graph where fx is equal to log of x base a, where a is greater than 1. And whenever they say you find out fx is equal to log x with base e, I told you e is always greater than 1, 2.7 nearly. So that means this will be this curve. So this curve will be also same. For this curve, if you want the shape directly, I can make. What the shape will be? The shape come out to be like this. This point is 0, 1. This will be the curve you are going to have. This is x-axis, this is y-axis. This is so this way you will be having the graph that will be called as logarithmic function. Then comes next function is reciprocal function. One function more is there, reciprocal function. Fx is 1 by x, reciprocal function. Fx is 1 by x. If you think about domain of this function, one thing is clear. What that is? X cannot be 0. Because if you put 0, then the image come out to be infinity. So we will say domain of the function will be all the real number I can put, positive or negative, but should not be 0. And just check the graph of this function again. 0, 1, 2, 3, 4, -1, -2, -3, 1, 2, 3, 4, -1, -2, -3, -4, so on. So now in this case, when you put 0, will it be possible? No. You have not allowed it because when you put it 0, it come out to be infinity. So not possible. At 0, it is infinity. When you put 1, x, when you put 1, fx comes out to be 1 again. So at 1, it's 1. When you put x2, fx will be 1 by 2. 1 by 2 means at 2, the value come out to be half here. When you put 3, it come out to be 1/3. So 3, it is 1/3. Same way now, I'll take the value between 0 and half, 1. That also I'll take. This was at 1, it's 1. 0 was not there, but you should take some values between 0 and 1 also. By the way, I'll take half now. When you take x as half, then it will come out to be 2. So at half, the value come out to be 2. When you put x as 1/3, fx come out to be 3. So that 1/3 is here, so it come out to be 3. So the graph goes like this. Same way when you go for negative side. When you go for negative side, 0 it does not define, -1 it's -1. When you go -2, what the value will be? -half. -half will be somewhere here, so it's here. Then -3 it's 1/3 here. Then we go for value between -1 and 0. -1 it's 1, then -half if I take, value goes 2. -1/3 I'll take, it will go 3. So the graph goes like this. It never touch positive x, positive y, negative x, positive x. Anywhere it is not going to take touch. That means x can never be 0, y can never be 0. So domain of the function is this. Range of the function, codomain is all the real number, no problem. Range is also all the real number except 0. Is it continuous function? We'll say no, it is not continuous. This function is not continuous. Why it is not continuous? At 0 it is going to break. So it is discontinuous at x is equal to 0. And if the function is discontinuous at x is equal to 0, no meaning of differentiability. So no differentiability is going to change. Discontinuous function it will be. One or two more small functions are left. We'll complete that, and next time we'll continue just discuss the continuity in an interval. Okay, thank you.